So now we're going to do 4-6, which is scale drawings and models. I added in a photo from the textbook so that you don't have to go look that up on your own. We're going to start off with the, when am I ever going to use this, on page 184. We're going to look at the floor plans, which is a blueprint for a bedroom that's given below. And the first question is, how many units wide is the room? And you're not supposed to look at the scale at all on this. You're just supposed to count the number of squares when we're looking on it. So we're going to see, looking at it from left to right, how many, that's outside the room. Inside the room, never mind the closet, how many squares do we go across? 1, 2, 3, 4, and count across. How far how wide is the room? Go ahead and answer that on number 1 up above. And I hope that you found that it was 9 units wide. All right, and then we're going to say we know that they're telling us that the actual width of the room is 18 feet. Write a ratio comparing the drawing width to the actual width. Well, we know that we have the drawing width, which is 9 units. We're going to write it as a ratio. We'll write it as a fraction here, 9 units. All right, and we're going to compare that to 18 feet. And that's basically it. That's all we want to do for number 2 there. Now, in the next question, it says, simplify the ratio you found and compare it. Well, if we simplify it, 9 is to 18, we can actually reduce that. 9 can become a 1, 18 become a 2, and we'll end up with 1 unit is to 2 feet. And we're supposed to compare it to the scale shown at the bottom. Is that what it shows down here? Yes, it does. All right, we have 1 unit is equal to 2 feet. Okay, so that's just a little warm-up to get us to be thinking about drawing scales and models in here. So what do we call something that we use to represent an object that is too large or too small to be drawn or built at actual size? We call that a scale drawing or a scale model. The scale is determined by the ratio of a given length on a drawing or model to its corresponding actual length, just like we showed in the map up here above. So we're going to use the map at the bottom of page 184. I've already put it in here for you to find the actual distance from the roller coaster to food court. If we know that the distance on the map that's shown there is 3.5 centimeters. We're going to use the scale of the map to answer the question and pay very close attention to the units in here. So first of all, we are going to set up a proportion to do this. Okay, so I'm actually going to just write a blank proportion here, some fraction equal to some fraction here. Okay, now it's important to realize that we're going to have, in this case here, we have 2 vertical categories or going this way, and they are in the same category going this way. There's either this or this. And then we also have 2 categories going horizontally, either this one or this one. So, and I'm going to show you what I mean by this in just a second here. When I look at, in this particular case, I look at the scale here. I have 1 centimeter in real life is equal to 10 meters in there as we set it up. So in this particular case, one of the categories is basically looking at the dimensions, the size in the various things. And so one of them is going to be centimeters in the map, and the other one is going to be actual meters in real life. And so we could call this the map, and we could call this the real distance here. And we could have put those horizontally instead of vertically, but I just set them up there as the vertical ones. And then we also know that we have a particular distance that we do know, and we have a particular scale that we know. So we have, in this case, we're going to have our scale, and then we're going to have our actual distances that we're trying to find out. So in this case here, we've been told our scale is going to be 1 centimeter on the map, which is up here, is going to be equal to the real distance, which is 10 meters in real life. And what they've told us is this actual measurement here of that red line is actually 3.5 centimeters, okay? That's on the map though, okay? So the actual measurement on, again, here's my actual, here's my map. that is going to be 3.5 centimeters. And what I'm trying to find, what I don't know, is this particular missing piece of what is the actual distance in real life. All right, and that's what I'm looking for, is this distance here. We'll call that D. Okay, so now we have a proportion set up. We have one missing piece of information. Now we simply go through the procedure of doing the cross multiplication. 1 times D is equal to the other cross products, which is going to be the 3.5 times the 10. Okay, we're multiplying, in this case here, we're multiplying these two across, and we're multiplying these two across. And because cross products in proportions are always equal to each other, we put an equals in between those two. So now we have D is equal to 3.5 times 10, which is 35. And there we go. Once we simplified it, we have our answer. That's 35. Remember that the real distance was a measurement in meters. So we found the actual distance to be 35 meters. Okay, and so what's the question? How the actual distance from the roller coaster. So we would write a sentence. The roller coaster is 35 meters from the food court. All right, there we have it written down. All right, we're going to take a look. Each column of the Lincoln Memorial is 44 feet tall. Michaela wants the columns of her model to be no more than 12 inches tall. Choose an appropriate scale and use it to determine how tall she should make the model of Lincoln's 19-foot statue. Okay, so once again, I'm going to set up a proportion, a blank proportion with a fraction equal a fraction in here. And I've already noted down here that one of them is going to be either I've noticed that I have a statue in here that we're looking at the Lincoln statue, and sometimes we're looking at the column there in the model. And then we're looking at the model that she's making, and we're also talking about the actual height of it of the in real life here. So we're looking in one sense at either the statue or the column, or model or real. And we could label those either way, whichever one that you want to do. So you may have set this up totally differently than me. It doesn't really matter as long as we have these same categories. And as long as when we cross multiply, we're going to get the same cross products. Now, in this case here, I've said, okay, this in this particular section over here, I'm looking at the statue and the model of the statue. So when I look at that here, I say, okay, I know that's actually the piece of information. Choose an appropriate scale and use it to determine how tall should she make it. That's the part that I don't know. Okay, so that is the actual model. Maybe I'll call that the M. That's the missing piece that I have. And here, the real statue is actually 19 feet tall. So I have statue, I have real. That's going to be 19 feet. All right, in here. And then I have the column. Does what I look at next. The column, the real column is actually 44 feet tall. So I'm going to put that in here. And this was kind of interesting. It says Michaela wants the columns of her model to be no more than 12 inches tall. So I could put in a 12 in right here. However, I'm looking at that 44 down below, and I'm saying, I want it to be no more than 12. It means I could choose something less. 12 doesn't quite go into 44. To make this easier, what's a number anywhere less than 12 that goes into 44 that I could use? Well, I decided to use 11 in there because it goes into 44 really easily. All right, so now I'm going to be able to set up I have my proportion all set up. Now it's time to cross multiply and set their products equal. I know that the M times the 44, so I can do 44 times M is one set of cross products. I know since this is proportional, there's an equal sign in there, that their cross products must be equal, and the other cross product is 19 times 11. Okay, so I'm going to get 44M is equal to 19 times 11, and I get 209 when I multiply that. Solving for M is being multiplied by 44, so I need to divide both sides by 44. And I get that M is equal to 4.75 inches, which means that the 19-foot statue, when I make it into a model, is going to be 4.75 inches or 4 3/4 inches tall. So all you need now is a little bit of practice on setting up these proportions. And remember that you're going to just have two categories going vertically, two going horizontally, and make sure that you just set it up in an organized fashion so that and as long as your cross products are always equal to each other, and you're getting the same cross products that I have on here, then you have been doing it the correct way. There are obviously incorrect ways. For example, had I switched these, the 11 and the 44 around, that would have gotten me totally the wrong thing. Then I would have had model is to real is to model. I need to make it model is to real as model is to real, and those have to stay the same. Statue of this has to go with column of this. So that's really, you can't go statue then column and then statue. There has to be the same things going in the same order.